What is up, guys? Welcome back to the series. In this episode we will go through building the planet comparison visual. So first we will be gathering the planet images, then modifying them in Pixlr and Figma so we can use them in the report. Then we will build the planet comparison visual so that we can display the planet size in a dynamical way. So let's get into it. To start with, we can create the images table. So we can go to the planets table and we can add the image URL column as a new query. Then we can convert the list to a table. Then we can split the column by delimiter. We can use question mark as the delimiter and the leftmost delimiter. Then we can delete the unnecessary column and rename the column as image URL. Next, we can create the image table. Now we can remove duplicates and we can copy the column. Now we can go to Excel, create a new workbook and paste the column here. And here we have the images. So we can rename the sheet as image URL and save the file. So we can navigate to our files folder. Then we can choose the CSV and we can name the file as images. Now we are ready to create the Python query to download all the images. So we can open up the notepad, we can open a new window. So first we can import the requests, then we can import the CSV module and the OS module. Now we can define the variable for our image directory, so image dir equals os.path.join, and then we will join the file path os.getCwed, so the current working directory, and we will call the new folder where we store the images as planet images. Then we can create the function os.makeDirs to create the directory. So we can call the above variable. So we will check if the directory already exists, and if it's true, it's still okay. So it will go ahead and still create the directory. Then we can define the download images. Here we can define the image URL, and then we can define where we'll be saving the images. So the image directory, image dir. Next we can create a try statement. We can do image_path, image path equals os.path.join. We can call the image directory and the image URL. So here we will basically split the image URLs and we will create the names for the images. So we can basically split the image URL from the last slash character where we have the planet name. Next we can create the response. Here we do a requests.get the image URL. So we will call the image URL in a web browser. Then we will do a response.raise for status, so we can check whether the request was successful to the web browser or not. Then we can define the CSV, so with open. So here we can call the image path, so the image name. So here we will call the image path, so the image name that we defined earlier from the folder as WEB, so write binary. Then we can define it as file. Next we can write the images to the folder with file.write from the response.content we defined above. Now we can create an except statement in case something goes wrong. So except request.exceptions.requestException and define that as E. Then in case the exception happens, we can print error downloading, and then we can input the URL where the error happened. Next we can define the download images from the CSV. So here we can define the CSV file, and again where we are uploading the images, so the image directory. We can create another with open statement, and here we can input the CSV file, and we can select the new line as blank. Then define it as CSV file. Here we can create a for loop for row in csv.dictReader and CSV, call the CSV file from above. Next we can call another with open statement, and then we can call the CSV file. We can set the new line as blank and define it as a CSV file. Then we can create a for loop for row in csv.dictReader, then call the CSV file. So basically we can iterate over the rows in the CSV with the dictionary reader. We can handle the rows as dictionary objects. Then we can call the download images we defined above. We can call the above for loop, so row.get the image URL, otherwise blank if there is none, and again from the image directory. So to end with, we can create an if condition. So if name equals main, we can call download images from CSV we defined above. Here we can input the name of the CSV file, so the images.csv, and again where it is located, so the image directory where we will be saving the downloaded images. Now we can save the file, save it as planetimages.python in our file directory. We can open the PowerShell and activate the virtual environment once more. Then we can call the script. Here we got an error, so it's a simple syntax error unfortunately, so we just had to add one colon back to the file, added the missing colon, say it again, and we can rerun. Now the script is ready, so we can see that on the bottom of the directory it created our folder, planet images, and when we open the folder we can see the planet images. So now they are ready for editing, so we can move on to Figma for editing. So next we can go to the image folder. We can paste all the images to Figma. So next we can go to Figma. We can open the planet images folder, and we can import all the images to Figma. So select all images, and then we can place them below our report design. Now we can start editing the individual planets. So as you can see, they are a little bit different, they are formatted a little bit different, and the size is a little bit different, and some of the images have also the star included. So the idea here is to basically crop the images first, so that only one planet is displayed per image. Once everything is cropped, we can go ahead and do some modifications for a couple of the images that have different measurements. So for example, the image that shows a close-up of the planet and then another planet in the distance, we can go ahead and make that planet complete. So here I'm creating an ellipse for the approximate planet size. Then I'm placing it behind the main image. Now I'm picking the color of the planet with the color picker tool, and then I'm recoloring the ellipse for the planet color. Next I'm creating some effects for the planet. So I'm placing a couple squares on the ellipse. So we can keep the pass-through effect, and then I'm placing an effect for the squares, so the layer blur, and I'm placing the value as 97 to get a blur effect. Then I'm cropping the main image, then I'm aligning it and selecting everything, and then creating a group and renaming the group as the planet images name. So now we can select everything and resize everything as 200 by 200 pixels to get an approximate even size. Here one of the planets was a little bit spherical, so I edited it closer to a circle. One of the planets was missing the top and the right side, so I created another ellipse, placed it behind the image and colored the ellipse near the planet's color. So fortunately we have some shades, so it's fairly simple to format. Here just placing some gradient to get a shade effect, and then grouping the elements and renaming it, the group as the planet's name. So now we can save the images to our planet images folder. Then I'm going to pixel our site and I'm uploading all the images to remove the background. So as you can see, some of the images look pretty good, but there is still some room for modification and a couple images that didn't really convert very well. So here I go to the fine tune section. I'm just restoring the circle, so we can just change the pixel size a little bit higher and then create one circle to get approximate circle and the planet displaying correctly. Here we can finish the rest of the planets that still didn't look quite right. So here I just repeat the same thing we did for the previous one. So I increase the size of the circle and then erase everything and then restore the image. Next we need the size comparison reference image for the planets. So we need one image of Earth and one image of Jupiter. So here I go to Google and I search for both Earth and Jupiter, downloading them to our images directory and then modifying in the similar fashion we did before for the other planets. So cropping the image and then resizing. Now removing the background for Earth and Jupiter and adding them into our planet images folder. So next we need a way to store the images and display them in Power BI. So here I decided to use the conversion from a PNG to a base 64 type. So how we can do the conversion? We can do the conversion in Power Query. So we can convert all the PNG files to a base 64 format and store them in the report as text values. Then later on we can concatenate text values in the report so that we can return the complete images. So here I go to Chris Webb's blog. He has a nice way of storing the images in the report as base 64 format. So we will use that one to display the images. I will include the link to this blog in the description. So here we can just copy the M query. Then we can go back to Power BI, open the Power Query. Then we can create a new blank query and paste the query from the blog here. So now we only need to change the file source path to our planet images folder, and then the planet images will be converted from the original file to base 64 format. As you can see, there's multiple rows in the pick column. So these are the converted values per image depending on the image size. So we will be concatenating these values back together with the DAX in the report. The only thing we need to do here is we can duplicate the name column. Then we can replace values and replace the .png with blank, so that we only get the name of the image. We can rename the column as planet, so changing the value in both the column duplication and replace value steps, and then the planet images table is ready. So here we need some key to join the columns in the data modeling view. So I just duplicated the image URL once more in the planet's main table. I split the column by delimiter, used the rightmost delimiter and the slash, and then split it again. Here we can use a dot to split it from the leftmost delimiter. And now we're left with the planet image names. Rename the column as image name. And now we can go to the data modeling view in Power BI and join the planets table and the planet images by the planet name column. We can use the many-to-many and both. Next we can create the concatenation measure. Which will join the base 64 image rows back together as one image. So as we don't have the measures table yet, we can create one now from the enter data section. So here I just rename it as dim measures, and now we can create the DAX. So naming it as planet images, and then if has one value, so the planet images name. So if it has the value of the name of the planet image, so here we can call the value as data :image /png semicolon base 64, then comma and space, and then we concatenate that with the function concatenate x. So here we call from the planet images table, call the picture, we call the pic as the expression, then we leave the delimiter as blank, and the order by expression we will use the index column. And then finally from top we can change the data category to image URL. Now to end with, I just removed the unnecessary column from the dim measures table, so that we are left with only the measure. Next we can go back to the report, and we can select the background we created in Figma from the images directory. So here I select the space.png, set the transparency as 0, and then we can start to design the elements that go into the boxes. So first we can create the measure for the planet size comparison. We can name it as AJ planet comparison for Earth Jupiter. We can start with creating the variable planet. Here we can calculate. We can choose the planet image measure, where the planet from the planet images equals the selected name from the planets table. Then we can create the variable for the comparison between Earth and Jupiter. So here we can say if the selected times planet radius is in x Jupiter or x Jupiter estimate, then we can calculate the planet image. We can choose all from the planets table, then the planet from the planet images equals Jupiter. Then we can duplicate the value and we can change it for the Earth. Next we can create the variable for the multiplier, so this will multiply the size of the planet. So for this we can just duplicate the values from comparison, and then we have to change the calculate the sum of the planet radius. We can copy it also for Earth, and then in the filter section we can say the name of the planet from the planets table equals the selected name from the planets table. Then we can say the planet times planet radius is in Jupiter and the times Jupiter estimate. And we can do the same for Earth. The name from planets table equals the selected name from the table, and then the planet x planet radius is in x Earth or the x Earth estimate. Next we can create the variable for the size. So here we can define the appropriate values for each planet size. So first, if the multiplier is more than 0.2 and the multiplier is less or equal to 0.5, then we can copy the value below, and we can say if the multiplier is more than 0.5 and the multiplier is less or equal to, and here we can change the values. So if the multiplier is more than 0.8 and if the multiplier is less than equal to 1.2, we can multiply 120 times 1. Then we can copy the value once more and we can input if the multiplier is more than 1.2 and the multiplier is less or equal to 1.5, then we can multiply 120 times 0.8. Then once more, copying the value below, you can say if the multiplier is more than 1.5 and the multiplier is less or equal to 1.8, then we can multiply 120 times 0.7. And if the multiplier is more than 1.8 and less or equal to 2.1, then we can multiply it by 0.6. And finally, if the multiplier is more than 2.1, then we can multiply 120 times 0.5. So now that we have all the sizes and the comparisons ready, we can go ahead and return the style for the measure. So we can create the CSS style element. We can input attribute image, where position is in the center, then the width is the size variable, and then pixels, then the height is also the size variable pixels, and then the object fit we can say contains. Then we can create another attribute. This is going to be for the center. So here we can say display is block, taking up full width of the container and starting on a new line. Margin, then margin left we can leave to auto, and the margin right we can also leave to auto. We can set the width as 50%. Then we can end the style block and we can call the center div class. Then below we can call the image class. We can use the image attribute and then the src, and we can input the comparison variable. Then we can end the divs. So now when we come back to the report, we have to define the filter so we are able to select between the planets and see if the comparison works. So now we can create a filter. So let's select the new filter from the visuals. Then we can input the name column from the planets table into the values section. Next we can remove the background. We can reduce the amount of rows to 2 and the amount of columns to 1. We can change the font to white, and then we can input the image URL from the planets table into the image field section so that we get the planet images visible with the name. Now when we have the HTML box above with our AG planet comparison measure, we can filter the planets and we can see that the first one is working with the Earth and the Jupiter. And now we can just duplicate the whole measure, we can paste it, and we can call the measure as planet comparison, as here we will be displaying the actual planets that we compare against Earth and Jupiter. So for the variable planets, we can change the planet images planet into planet's name equals the selected name from the planets table, so that we can display the planet images. Then we have to do some modifications for the size variable. So here, instead of the fixed 120 pixels, we can input our multiplier variable, and then below in the image CSS block, in the image CSS attribute, we can input the 120 pixels, and then we can multiply that by the size. We can do it for both width and height. Then below we can change the comparison variable into the planets variable to display the planets. And now we can duplicate the HTML visual. We can put it besides the Earth and Jupiter, and then we can input the planet comparison measure. Now you can see the exoplanets displaying, and when we filter the planets, you can see that the planet's size changes accordingly compared to Earth or Jupiter. Now when the HTML when the planet comparison HTML is ready, we can create the title for the planet comparison. So here I'm creating a new measure, calling it planet radius, then doing a variable radius. So here we calculate the selected planet radius, where the planet from the planets table is the selected planet, and we concatenate the planet name with the selected planet radius. Then we can return, we can create a CSS style block. Let's create attribute value called value. The color is white, so F6 times, and the font size 20. Then we can end the style block. So here we can call the div class equals value as value. Then we can concatenate the variable radius and end div. Here I forgot to add pixels to the font size, so added it. Let's also make the text bold. Now we can create another HTML visual, place it above the planets in the planet comparison, align it to the center. I changed the font to DIN from the HTML visual settings, align it to the center, and the planet comparison visual is ready. And there you go, guys, we have our first visual ready. I know that took a while and the planet images were a bit manual, so maybe you will find a better approach to create or even automate it. Anyways, that's done, so we can move to the next one. So in the next episode we will be moving to the stars and getting the different type of stars and building the distance from star visual. If you like this content, leave a like, subscribe, and see you in the next one.